Okay, maybe just so I can calibrate my talk, raise your hand if you came to the ZK email workshop, at least one ZK email workshop, or talk or anything. Okay, that's like almost everybody. Okay, so in that case, I think what I'll do is I'm going to give a diff of what our team did in those 1 or 2 weeks, and then I'm not going to repeat any of that other stuff, or I'll spend a max of like 30 seconds on that stuff, and that way people who can't follow previous stuff can still get a sense of what's going on, but then you get the diff. Okay, so that's basically this demo we gave. So this should only take like, I know we're like 15, 20 minutes over, so I'm going to try to keep this whole thing to like 5 minutes. Okay, so for the 3 people who don't know what ZK email is, your emails are signed according to the DKIM protocol and RSA signature of a hash. We make a ZK proof of that RSA signature and hash and use regex and substrings to parse out the data we want to remove. This makes it provenant because we're verifying the mail server directly, programmable because you can reveal what you want to privately, and you can verify it on chain. We talked about some whistleblowing stuff. This site where you can kind of redact specific parts of the text and reveal it, we're going to put that live probably in a week or so. So that's just one interesting thing. The domain marketplace is still up, the ZK-P2P thing where you prove you did a namecheap transfer and you pay for it. So people should try selling domains on this. It's actually like a really nice flow. You like, yeah, Sachin was here earlier, maybe he left. I mean, he's still back there. So yeah, everyone should try this out. We demoed the SDK registry 2 weeks ago where people can go make proofs. And the main issue people had in Invincible Garden was that there was like some misunderstandings on the validations of like what regexes worked and what didn't. And so what we added is 2 things. Because literally the workshop we did here, we added one thing where you can upload a test email and you can validate before submitting whether your test email passes. You can iterate on that. So hopefully that'll stop all of the like, I think maybe like half the people who use the Garden push like broken proofs. And so that should make sure no more broken proofs get pushed. And then the last thing is we have way more aggressive validation on the field. So like, I think a bunch of people put stuff that was just like invalid, like the headers were too short and the regex was wrong and all that stuff. And now we'll validate all of that. So it's like very hard to submit something incorrectly. So that's one diff on the people who saw this 2 weeks ago. And then I think we also updated the ChatGPT bot. So I think people are having trouble with the ChatGPT bot. That's now been updated. So this should make all the patterns like way easier to do. Yeah, I'll give people like 2 minutes to, or like 10 seconds to scan this. Sweet. Yeah, I don't know if I showed these, but some of these were folks from here actually. But I'll just give a preview of some of the stuff that folks have pushed the SDK. Verifying a DocuSign document, verifying you took some flight on American Airlines, and showing the to and from, proving you're part of a Slack workspace, proving you exported some data from LinkedIn, and then you sell that data to like somebody who wants to buy it, like usually AI training company. Prove you exported your OpenAI data that then Anthropic buys. Prove you ordered pad thai in Thailand on Grab, which is pretty fun. And the classic prove you got rejected from DevCon. Right, and then one thing I didn't present last time is that we're also working on a bunch of JWT stuff, so you can prove that you logged in with Google and you signed some message, which then gets directly sent on chain. This can just be a transaction hash. And then we're also doing, this SDK also supports like proving you own a domain, like, oh, I prove I own at Microsoft.com or whatever. And the hope is that, and you can also prove you are like one of many domains. So we have like Merkle tree as an option, so you can say, oh, I am like part of a Paradigm Portco or something like that. And then the problem with these proofs is that you want to do moderation. So how do you do moderation? You use TEEs for that. So basically say, we'll take the, because you can use TEEs for non-security critical, or things where point in time, where you don't need security criticalness for long periods of time. And so what we do for this is you can basically say oh, I'm going to prove to you I am authorized to post this anonymous message board. Oh, I have an @boeing.com email, and I'm posting this statement about myself. And a statement you have to make sure there's no hate speech or whatever. So you send that to OpenAI's API or something, you prove there's no hate speech, and then it comes back, and then you allow it to post. And ideally, once Ezekiel can support GPT-3, then we can just do that with ZKML. But until then, we're kind of using TEEs as a band-aid there. Cool. Yeah, that was most of the use cases. Dev tooling. People who came last week saw a demo of generic relayer. This is at proof.email/docs. I can kind of put a QR code up for that. We actually, let me see. So last time we did the workshop last week, there was some problems where people, basically like ideally there would have been a quick start for folks. Like folks had to like fill in the repo, download a bunch of stuff, it didn't work on people's system, and now it's like a one click, you like, in the docs there's a quick start, you clone the thing, and everything's set up for you, and there's a make script that does all the stuff we did in the workshop. So like the workshop that took us an hour is now like a 5-minute thing, which is kind of cool. Yeah, so for the people who weren't at the workshop, the idea was you could define a Solidity function like recover account ETH address to owner ETH address, and then call our API, and then the idea that you could then iterate on ZK email proofs in Solidity really fast. And so this is what we have now. Our docs, I think people who came to SDK workshop, it was not like this. People who came to the generic relay workshop, it was like this. Yeah, they're a lot cleaner now. This was an improvement we made maybe 2 weeks ago, is we pushed out GPU and everything, so now all the server-side proofs are at least like about 7-8 times faster. And soon we'll also have post-narcs on that, so then server-side proofs will also have like, theoretically some privacy, but it's like a non-collusion privacy, so like fake privacy. But anyways, it's better than just like a single machine. And then fast client-side proofs, so I don't remember if I talked about this, but we're also iterating on some of the Noir stuff. Unfortunately, the regex doesn't, like regex in Noir doesn't work because Noir is not efficient enough, but everything else should work in Noir. So if you want to do fast client-side proofs, ZKML.NR is starting the audit today, actually, which is quite cool. And then this is not as relevant for the devs here, but we are still releasing account recovery on mainnet. So you can kind of recover your safe account, your played account. And so those are getting audited, and if people want to build like account recovery for X wallet, that should be fairly easy with the fully edited code. Cool. Yeah, so if folks want to learn more, zk.email is good, and the slides are on there. Sweet. Almost exactly 5 minutes. Do people have questions?
May I ask, you mentioned you're going to do co-stars, right?
Yeah.
How are you going to do this? Like, are you going to use like Noir, recent Noir developments for that?
Yeah, you mean the Noir co-star bounty,
yes,
right?
Yes.
Yeah, so that one is, so Noir, the Noir co-star bounty is basically Tasio saying we'll build like a backend for Noir proofs. I think the main problem with that right now is that they only support CPU, and I think GPU support is like coming in the next month or something like that. Right, so as soon as they release GPU support, then the server-side proofs will use like a co-snark. And then the idea is, okay, at least there's like no PII link unless you include. Yeah, that's no problem. Cool, any other questions? All right, I'll be outside if you want to ask more questions, but cool. Glad this was useful for people who had heard of the email before. Okay. Who's next?
Hi guys, Chris here. I'm going to talk to you about TLS node tree, but before I start, I just want to have a show of hand. Who knows what TLS node tree is trying to solve and what's the use cases? Okay, I guess majority of you. So I'm going to go really quick in the first half for people who don't know. So TLS node tree is a project that's trying to solve data provenance, but to understand that, we need to know what TLS is. I guess everyone should have heard of it. Basically, it's as in HTTPS, it's the protocol that secures internet communication between the server and the user. There's something missing in TLS, and that thing is data portability. Basically, you can't just show the data that you get from a server and prove it to someone else. For example, like Alice couldn't just show a bank statement to Bob and convince him that the bank statement is real, because Alice might have faked it. So Bob always have to rely on some alternative, like some trusted parties or the source itself, to check whether data is true. So that's what we meant by data portability. And TLS Notary is able to provide that while not depending on any trusted third parties or the server itself, and also privacy is preserved. Just one example, just a thought experiment, like if you want to build a Web3 Uber competitor, you need some good drivers. So why not leverage the drivers from Uber.com itself, because they have so many drivers driving for them already. You can get these drivers to generate like a proof of their driver profile using TLS Notary, and they can prove these ratings or reviews that they have on Uber.com to your platform, which is which one. And that whole process is transparent to Uber, which is perfect because Uber can't censor this usage. And you can even make it more privacy preserving, where you can make like an anonymous driver platform if you want. And this is basically not just restricted to or limited to Web3. There's a lot of Web3 use cases as well. Like if you want to if you want to leverage any data that's sitting in the Web2 server that uses TLS, which is practically almost everyone. So you can go from data like identity to financial, social, as long as your platform requires as long as your platform can leverage on some data from Web2 server, you can use TLS Notary. And so yeah, these are some of the use cases that are already deployed in the wild. ZKP2P, what Sachin mentioned just now, and a few others. And yeah, okay. So now it's, I guess, the more interesting bit, how it actually works. So this is original TLS. So TLS basically secures communication between two parties, and that means there is cryptographic key involved. The keys are symmetric. So there's a process called key exchange that allows this key to be derived. And so, for example, like elliptic curve Diffie-Hellman is one such process. So the yellow keys are the session keys that are derived, and they're symmetric, they're the same, owned by both the server and the prover. They use those keys to encrypt and decrypt response, and that's why these requests and response are encrypted and not able to be tampered by anyone in the middle. This is what it looks like in MPC TLS, which is what TLS Notary use. If you look at the left side, the server is still the same. They still only have they also still just have the full server key, the yellow key. But on the right side, instead of just one party, you have two different parties right now. You have the prover is just the client just now, but you have this extra entity called the verifier. And this prover and verifier now don't have the full key to themselves anymore. They only have shares of the key. If you look at the red yellow key and blue yellow key there. So this is very important, and I'll come to that later. But essentially, the keys are being split, and that is done via MPC, multi-party computation. Just make sure everyone knows what MPC is on a high level. Cool, okay. Yeah. Encryption in MPC TLS, this is the part where both the prover and the verifier needs to cooperate together with their secrets, with one private input in this case, which is the TLS key share. And now they can cooperate and engage in this MPC encryption to compute the ciphertext that is basically the request, the encrypted request that needs to be sent to the server. And during this process, the prover actually also commits to the plain text request, because later on he needs to prove that that plain text request actually gets encrypted to the ciphertext that the verifier knows, so that the verifier can be convinced that he hasn't done anything sketchy when sending the request. Yeah, and also at the same time, the verifier doesn't see the plain text because it's a private input. Decryption is pretty similar. They also have to cooperate to decrypt the response, and also the prover has to commit to the plain text response that's decrypted. because that is private to the prover, because we don't want, at this stage, we don't want anything to be known by the verifier. So the verifier is kind of blind in this case. And the verifier also doesn't know who the server is yet in this case. So it's completely blind to the verifier, and the prover basically commits to the plain text, and that's and also later prove that it encrypts the ciphertext, and that's able to convince the verifier that this response plain text has not been tampered with by the prover. So that is the MPC TLS process, the encryption and decryption done in MPC. Now we enter the verification process. So the verifier has an objective in the beginning, which is trying to verify this data that belongs to the user that sits in the web server. So now he needs to verify the data. So there are two ways that they can verify the data. The prover can show everything to the verifier in the raw plain text, and the verifier is able to be convinced that this raw plain text is not tampered with because of the process that I described just now. Or for privacy preserving purpose, the prover can also redact certain fields in those, we call it transcript, basically just a data that contains the request and response from that TLS session just now. So anything that's sensitive or not required by the verifier, the prover can redact it. And to take it even further, they can do ZKP on top of that request and response transcript to not reveal anything at all, but just proving a statement. So that is kind of like the entire flow of the protocol. And this, it's more for on-chain use cases, because for on-chain smart contract, on-chain verification, this on-chain entity needs to rely on an off-chain component, because the whole MPC TLS process is interactive, so we can't expect the on-chain component to perform that. And so there's a trusted verifier that needs to be relied on. And this brings us to this setup we call the notary, which is part of the name, TLS notary. And essentially, the notary is kind of like a entity that only does MPC TLS and is blind to the entire process. But the output of this setup is where an attestation is signed by the notary, and this attestation is able to be used to be used with multiple verifiers. So, for example, you could notarize your government data, and then that same attestation that's generated by the notary can be used with like multiple different verifiers, proving different things, like proving age, proving name, proving address. So you only do the MPC TLS process once, which is pretty neat. And yeah, in terms of the development experience, team has built a browser extension with a plugin system. So this is going to be used by the prover, which is the user that wants to prove something in their server, wants to prove some data in their server. And so for any developer who wants to notarize a specific type of data, they can just write a plugin, which is an XDism plugin that compiles to WASM, and that can be imported into the extension. And the core library is all built in Rust, it's open source, and yeah, this is a QR to a quick start guide if anyone wants to check it out. Yeah, I'm just going to leave it there for a while. Okay. And more links, everything is in the website, so you could also scan this to get access to the website, GitHub, support link, documentation. Well, how are we doing with time? Do I still have 5 minutes? Okay. Cool, okay, so yeah, I guess I have some time, maybe a quick demo. So this is basically showing how the prover wants to prove that he received a DM, maybe from Vitalik, to like a verifier, just like a fun thought experiment. So that's it. Okay. So the top part is the prover perspective, the user perspective. The bottom part is the verifier. So the user now is installing a plugin, the plugin that I talked about just now, and that plugin will guide his UI to this panel, and that panel has some instruction that asks him to browse his Twitter DM page and select the DM that he wants to prove, and that now it gets notarized by the verifier down there. So this still takes some time, and it's still something that we're working on to improve the speed. And Yeah, so once the attestation or the proof is ready, you can access it from the plugin. Yeah, and you can see that things are redacted because we want to hide some off-token private stuff, and you can also download the attestation and use it. So this is kind of like the reusable attestation stuff that I talked about. Yeah, so I pause there, and I think that's my last slide. Yeah.